Hey everyone, welcome to Electrofun. In today's video, we will see how we can analyze a protocol using analog discovery 2. So in my previous video, I have explained how to interface MLX90614 non-contact based temperature sensor with STM32. So the setup with that remains the same. All I will do right now is use those clock and data lines with AD2, read the protocol and try to make sense of that protocol. So let's get started. Now, the analog discovery 2 is capable of a lot of things. We can use it as a waveform generator, as an oscilloscope. It also has a logic analyzer. So today we will use that functionality. Now, this set of cables comes with a box of AD2 and there's a small notch over here. So what I'll do is I'll just connect this. Once we have that properly connected, now how can we understand what this pinout means? So in every AD2, in the box of AD2, we have this, when we take out all of this, so this is how it is. When we take this off, there's a pinout that is given over here. And as you can see, it's very clear and understanding. So AD2 is also capable of generating power source with this V plus and V minus or V plus and ground. So we can generate 3.3 volts, 5 volts. That that can be used when we want to drive like the whole circuit with AD2. But right now we are not doing that. We are keeping the powering up with STM. All we want to do is we use some digital IO pins with my clock and data and analyze the protocol, analyze the I2C protocol. So we'll use three pins over here. We'll use the ground so that we have a common ground between STM32 and AD2, and we'll use 0 and 1. That's nothing but the digital pins which we want to analyze. So let's do the connections. Now I have this male to male wire over here. What I'll do is I'll connect this to ground. The gray one is ground, and the ground over here is the third pin from here, and there's a small marking also over here if it's quite visible. So I'll take this, I'll connect this. Now I will connect the clock, which is the blue one over here, and then I'll use one of the digital pins. So pink over here goes to clock, and then I will connect the data, which is the purple or violet, I would say, and then that goes to digital pin 1. They've done quite a good job with the color labels as well. So if I look over here, this 0 that I connected as clock is actually pink wire over here, and then the one that I connected with data is actually green wire over here. So that's quite good, helps with risk management and getting the connections correct. So let's move on to the software now. So now coming to the setup over here. So I have my serial terminal. I'll press reset. I get a message. That is what we have programmed it for. And then I use STM Studio to continuously read the variable temperature that holds my decoded value. I'll just play that and I get the temperature, that is the current temperature. I put my finger over here and it increases as it is supposed to. Read my body temperature. As I get closer, it increases more. So this is where we had stopped when we interfaced the MLX sensor with STM32. Now let's open the software for analog discovery 2. We'll go to logic over here and I'll maximize that, and I'll add channel. So As you can see, there are a bunch of other protocols that we can decode: SPI, UART, CAN, HDMI. So they have a lot of options. I'll do I2C, and then clock is DI0, and this is taken by default. But if it is not, you can just change it whatever you want over here. But I've kept it that way. Now both of that are already added right now. Clock is on 0 and data is on 1. And what I can do is just run. So we see bunch of things going on over here. Now let us understand what is happening. First, we'll do that to protocol. We will trigger that on, let's say, address. My address was 0x5a. Okay. So now we are able to stop that because there's a trigger. Now I will just zoom that a little bit just to see what is happening over there. Now, before that, I'll just connect my mouse so that I can explain you better when I zoom and zoom out. So this is my whole frame that I see over here. So let me just make this a little bit much cleaner. I have the clock. This is my clock, and this is my data. And as you see, when we do the protocol I2C, it does all the hard job for us, which is decoding on every rising edge of the clock. So we send 5A. Now the best way to understand that is with the datasheet and tallying that with the datasheet. So this is my SM bus communication example. What it does is, this is exactly what we are doing over here. We send some slave address with the right value over here. Then we send the command, we send the read address, and then we get the data in 16-bit format, which is the LSB byte first and the MSB byte first, after that, sorry. And then there's some error checking, and then we do some math as we were doing it over here. So we read the data into the I2C data variable, we shift that data, we OR that data, so that now we have the MSB data and the LSB data as one 16-bit data, and then we multiply that with some value and then subtract that by some value. Now how everything will make sense, I will just walk you through that. Now this is the communication example. We see that at every rising edge of the clock we have some data, and that is what this software does for us. We have this 5A write, then we have acknowledgement. That is how exactly it is supposed to be, like start bit, address, slave address, acknowledgement, then the EEPROM address that we want to read, acknowledgement again, then this read thing, or read address, acknowledgement again, and then we have the data over here, which is this DB, acknowledge, and 3A. This is basically my LSB and acknowledgement, and this is my MSB, acknowledgement, and the stop. So this is how the whole protocol works. Now let us just understand what is happening. So come to programmer, and then I'll do hex over here. So we have the LSB data, which is, let's say, I'll stop over here for a while, which is D7 3A. So LSB is D7. Now coming back to the data sheet, LSB is D2 over here and MSB is 3A. So that makes the result as 3A D2, because most significant bit will come first with the least significant bit. So here it's 3A D7. So I'll just write that 3A D7. Now that is some value. I don't know what that means and why we have that, but this is what it means. So we have a value in hex, which is a 16-bit data. Now what does that mean in decimal? It's 15063, and when we multiply that by 15063, and we multiply that by 0.02 and then subtract by 273.15, it will give me a temperature value. And then when I come over here, I play it. So roughly it's a real time thing. So I took this value of 28.11 degrees Celsius a time before, and then I just took it right now. So this is how all makes sense. You read the data, you ship that data, you decode that data with the value that is given in the data sheet, and then you actually get that temperature in degrees Celsius from all that raw temperature. So this is all about how you can use analog discovery to decode your I2C protocol, match that with the data sheet, and make it work, or make the sense of what is happening over here and why is it happening the way it is happening. I hope you have understood this video. If you have any doubts, you can ask me in the comment section below. I will try to answer all of them. Till then, see you. Take care. Bye bye.